Problem 14. Got 9 integrals to do, so let's go ahead and do those. So first one, x cubed plus 6x squared plus 4x minus 2. First, you have to know that if I just write the integral sign with nothing else, all I'm looking for is an antiderivative. So these problems really aren't going to be that different from number 1, just extra practice and worded in a different way, but still very much worth doing. So here, by power rule, so this is the unique time that I'll actually write out the power rule. Every other time I'm just going to make a shortcut. But if I use the power rule, I get x to the 3 plus 1 over 3 plus 1, 6x to the 2 plus 1 over 2 plus 1, plus 4x to the 1 plus 1 over 1 plus 1, minus 2x, plus my constant of integration c. Can't forget that. And I'm left with x cubed over 4 plus 2x cubed, 6 divided by 3 is 2, 2x cubed plus 2x squared minus 2x plus c. And that's all there is to that. 100% just the use of the power rule. So b, now we've got the integral of cosine of x plus sine of x dx. And this is a similar idea. You just kind of have to know what the integrals of cosine and sine are. So here, if I find an antiderivative of cosine, I need minus sine of x. And if I want a derivative of sine, I need plus cosine of x plus c. So this problem just comes down to knowing the derivative of the trig functions, or how these relate, derivatives and antiderivatives wise. Part C, evaluate the integral of r squared plus r plus 14 over square root of r dr. This is the integral of r squared plus r plus 14 times r to the minus 1/2 dr. And from here, this just becomes a power rule problem. Equals r to the 3/2 plus r to the 1/2 plus 14 r to the minus 1/2. And I'm taking an integral of that. So this is equal to r to the 5/2 times the reciprocal 2/5 plus 2/3 r to the 3/2 plus 2 over 1, 14 r to the 1/2 plus my constant of integration so I don't forget it. And this really doesn't simplify much. 2/5 r to the 5/2. Let me write that so it's not confusing. 2/5 r to the 5/2 plus 2/3 r to the 3/2 plus 28 r to the 1/2 plus my constant of integration c. Oops, d, not b. Okay, the integral of x over x minus 1. Wait, this one might not work actually. So this was the goal to do this. Yeah, okay. So this does not quite work. But there's an easy fix. square this and make this a 1. No, I can still have that be an x, actually. It's fine if that's an x. Let's make this a cubed to be safe. Editing while we go. Not the best idea, but here we are. Okay. So what's the major trick? Let u be equal to x minus 1. So then du is just equal to dx. So I get this is equal to the integral of, well, x is equal to u plus 1. So I'm going to have u plus 1 over u cubed du equals the integral of 1 over u squared plus 1 over u cubed. I can split up that fraction and then the u's are going to cancel. Du equals integral of u to the minus 2 plus u to the minus 3 du. Now we use the power rule. So I get minus u to the minus 1 minus 1/2 u to the minus 2 plus c. And now I can write this in terms of x's. So I'm going to get minus 1 over x minus 1 minus 1/2 x to the minus 1 squared plus c. So I need to make sure that I fix this integral on the review sheet. But if we change it to x over x minus 1 cubed, then this works out. And this is one where you almost definitely wouldn't just guess that that's the integral. It takes a little bit of doing, and that's why u substitution is nice. Let's keep going. Part E. So I have the integral of x cubed secant squared of x to the 4th dx. So I see a secant squared, so I want to go for a tangent. So now my question is there some way I can get rid of this x to the 4th? So my first thought is u equals x to the 4th. Now I'm scanning to see, do I have an x to the 3rd out here? And I do. It's right there. So du is equal to 4x cubed. Well, I don't have 4x cubed, but that's okay, because I can pretend like I do. Because 1 is equal to 1/4 times 4. So I can say, well, I really do have 4x cubes, and then secretly multiply by 1/4 out front. Secant squared x to the 4th dx. I'll show a different way to do this that maybe doesn't seem so tricky. Equals 1/4 integral of secant squared of u du. Because I've got 4x cubed dx, that's equal to du. These two come together to make a du. And these two come together to give me u. So now this is 1/4 times the integral of, not integral, 1/4 tangent u plus c, and then plugging back in 1/4 tangent of x to the 4th plus c. So that's part E. Okay. So what was the not tricky way to do this? So here at this step I had x cubed secant squared x to the 4th dx. And I could have said dx solving over here is equal to du divided by 4x cubed. So then this would become x cubed secant squared x to the 4th. Let me replace that with u. Secant squared u times du over 4x cubed. Now the x cubeds cancel, and the 1 out of the 4 pulls out, just like we have earlier. So that's a less tricksy way of doing it. Okay, so we're on F. Just got over halfway done. So I've got secant, what letter did I use? S, times tan S plus secant of S. And I'm taking an integral with respect to S. So I see secants and tangents. I don't see anything I can do at first, so I'm desperate, so I'm going to distribute. And I get integral of secant S tangent S plus secant squared of S ds equals integral secant S ds secant tan S ds plus integral secant squared S ds. And this is equal to secant x plus tangent S plus c, just from knowing those derivatives. All right, 2/3 of the way done. G, let's find the integral of the square root of x to the 5th. So this one kind of looks like it would be super tricky, but it's not too bad, because I just write this as the integral of x to the 5/2, because taking a square root is the same thing as taking something to the 1/2 power. And I get this is equal to 2 over 7 x to the 7/2 plus c. So again, just that regular, don't think of it as a square root, think of it as a to the 1/2 power. And I'm going to move on to the next page because I might need all of it. This next one's probably the longest. Okay, good enough. So now we want to integrate, but not in pink, and not a 2. Integrate 2x cosine of tangent of x squared times secant squared of x squared dx. Okay. So you look at this and you say, my goodness, this is a mess. But I see an x squared and I see a 2x, so maybe that's the way to get a foothold. So let u be equal to x squared, then du is equal to 2x dx. Okay, so then this integral becomes integral, I have a 2x dx, so I can now just replace everything every time I see an x squared with a u. So I have cosine of tan of u times secant squared of u du. And now this integral seems a lot less scary, but I look and I think, oh, I still have a function inside of another function. And this was an example we couldn't do in class, but it is possible to have to do more than one u substitution. So I'm going to let u, v, be equal to tan u, then v squared is equal to, not tan, secant squared of u du, and I have both those things. So this becomes the integral of cosine v dv. Also, I don't know why I wrote v squared, I meant dv. And so we get minus sine of v dv. And then what do we get from here? not dv, sorry, plus c equals minus sine of tangent u plus c, plugging in v for v equals tan u, equals minus sine of tan of x squared plus c. So what happened is we secretly had to undo two chain rules that happened, which is why we had to make two u substitutions to do this. Okay. So next up, the last integral. Integrate cosecant cubed x, cotangent x, dx. So this at first might look a little bit worrying. Okay, I don't have anything I want. What's the trick? For ones like this, you have to either see, could I somehow make cotangent of x the u? That doesn't seem reasonable here because I would need some cosecant cubed stuff, squared stuff, I mean. But let's try making u equal to cosecant. Well then, du is cosecant x cotangent x. And can I get that from here? The answer is yes. Integral. So I'm going to take out two of the cosecants. They're going to be on their own. And then I'm going to have a cosecant x tangent x out here. So I've borrowed a cosecant from that cosecant cube to get my du. Sorry, this isn't a tan, it's a cotan. Ramping up on the mistakes now. But I'm borrowing the cosecant from that so it can be with the du. So then this becomes integral of u squared du equals 1/3 u cubed plus c equals 1/3 cosecant of x cubed plus c. And that's how we go. So these are all the indefinite integrals. This is incredible practice. And if you're taking Cal 2, highly recommend you make sure you understand what's going on here. And otherwise, I'll see you for the definite integrals.